All right, welcome back from our short break. We're in the home stretch of this year's conference. Want to welcome Damien, Hemal, and Jason talking about the future of OCP NIC.
Thanks, John. Hi, I'm Damien, technical lead of Meta. I'm also the OCP NIC subproject lead. Hemal.
Hi, I'm Hemal, architect at Broadcom. Also been working on OCP NIC from the day one.
I'm Jason Rock. I work at Dell. I'm a hardware architect, also working with the OCP NIC. And speaking of, we had a pretty big year in the NIC area.
So yeah, this year we did a couple of things. So last year we kind of introduced a TSFF thermal test fixtures. However, this one is a bomber. So NVIDIA came and talked to us and said, hey, it seems that we have a bug here. And then, what is it? Basically it's this. The thermal test fixture ideally to be mimic a system condition. And for our case, we made it too good. The test fixture get more air than it is actually supposed to be, that the air kind of converge and force the air out of the NIC area, that in the real system is actually having some kind of leakage air. So the test fixture is better than the system, so there's a bad thing.
Yeah, and I'll get a little more in depth of that in the next presentation, but the goal of that is to have predictable performance, and that's not the way to do it.
Yeah, and it is okay to be the test fixture to be a bit more pessimistic in that case.
Exactly.
So there are a couple kind of ways to solve it, and we decided to add more holes onto those front panel there that you can slap it on to fix the test fixture per se. And Jason have some of it, and if you want, Jason can send you some.
Exactly.
And the next area that we work on is a big one, PCIe Gen5 access test fixture. And speaking about it, Jason, you have presented it and contributed, right?
Yeah, no, I'll definitely cover that here. So we have a few slides on this particular part of what we did for Gen 5.
Yep, it's contributed as well. And we also work on the 800G and PCIe Gen6 introduction and all those things that we do pre-simulations, and which Hemal going to cover some of this in the later slides.
All right, thanks, Damien. Yeah. So before I get into 800 gig and PCIe Gen6 support, that what we are working on, at this OCP, you probably heard so many AI/ML presentation and all those infrastructure and 800 gig and why we need all this bandwidth. But if you trace all those paths, eventually it comes to that NIC, which has to support 800 gig. That's where our OCP NIC team comes into picture.
Yep.
So looking at all those things happening with our 1.3 version that we already released, this is something we are working on for our next generation. So we will be adding 800 gig support. So to add 800 gig support from OCP NIC spec standpoint, we have to define the connectors, which will allow us to have that kind of 800 gig connectivity. So the couple of ones which are listed here, QSFP112DD and QSFP OSFP1112. And then if you look at most of the primary port configuration for this kind of market are going to be either a single port of 800 gig or 2 ports of 400 gig. So this is our current possible port configuration that we are going to define. If there is also need or use cases for 4-port, we have also in the past done 4-port config in the OCP NIC spec. So we'll also look at that. Now, when you look at 800 gig, we are talking about 800 gig in each direction from the network side. So we need the host sites to also catch up, and that's where PCIe comes into picture. So today, what we have is Gen 5 support, and in small form factor, you can have Gen 5 by 16, which won't be sufficient for 800 gig connectivity. So this will require us to also update the Gen 6 by 16 connectivity. So Damien, I think you were... Yeah, go ahead.
And yeah, based on what we have seen is like the same connector on the PCIe side for SFF T810.002, those are capable to run at PCIe Gen 6. So that part is not changing. And like just I have Hemal have mentioned about like possible port configuration. The reason why we say possible, because ultimately in a small factor, whether you actually can do 2x400G or so, it's really depending how big is the ASIC. And depending whether you use is 2x400G in QSFP or maybe it's OSFP. OSFP is longer. So where to place the ASIC is a challenge. So that's why we say it's possible, but it's something that is a trade-off where you want to put it. It may be a limitation. And further down the slide, we have some new form factor we want to share with you that may help you in doing more ports.
Yeah, especially within this small form factor, if you look at the size of it and the fact that for this longer connector, you're only able to get one port and then an ASIC next to it. Exactly. We're going to need a larger form factor for something like this.
Yep.
Yeah, and so far I think small form factor is the most popular in terms of deployment that we have seen, but you will see why we are thinking about this new form factor.
Yes, that's exactly true. And that's why we look at the small form factor first, since that is the widely adopted one.
Yep. Okay, so this one, now let's talk about Gen 6 support. What you see on the table there, this is the table that has been circulating from the proposal standpoint. This is what we want to target for insertion loss. And several companies have been working on defining this. Again, this is a proposal. Eventually, it will get to the standard. And what you can see in the chart there, the channel simulation really shows that with this kind of insertion loss, we are seeing pretty good eye from the PCIe standpoint. So we feel pretty confident that these numbers that you see here as a proposal, that an OCP NIC from the spec standpoint, we should be able to define an implementation will be able to meet. That being said, this is just the beginning. We will need really careful system design and consideration before we finalize all that. So you are seeing the snapshot of what we are currently thinking. Other thing about Gen 6 is, as you know, Gen 6 from the lane standpoint, that's true, but from the spec standpoint, PCIe spec compliance we are going to seek for was 6.1. The reason for that is between 6.0 and 6.1, there were several significant changes, erratas, fixes. So our focus from the spec standpoint will be compliance with 6.1 spec. And we will keep the lane configuration that we have for our SFF and tall SFF factor, 16 lanes there. And then for large form factor, it will have 32 lanes. Damien and Jason, we were just talking about a minute before, we'll get into a new form factor which we are looking into. So we'll cover that later. And then, as you know, Gen 6 from PCIe standpoint was a big rev of the spec. And then it added both flit mode and not flit mode. So we need to also have both modes supported, and from the OCP NIC standpoint, make sure we have that fully into consideration when we talk about Gen 6. So that's our current thinking about adding Gen 6 support that goes along with 800 gig. Jason, Damien, you guys want to add anything to Gen 6?
Yeah, one thing maybe to add is more like, there's a formula there, but you kind of put in, you substitute this formula like frequency into the insertion loss, it became 6 dB.
Right.
So
it's about a dB more that the NIC now has to carry.
Yeah, it's a dB less, right?
Sorry.
Yeah, it's a dB less compared to the PCIe Gen 5.
Polarity.
Despite the same nyquist frequency, because PCIe Gen 6, the overall insertion loss budget is less. So every devices through the channel have to chip in a little bit. So that's why we propose in the OCP NIC. We do a dB less.
Yeah, and then prior from what
channel.
we had, Gen 5 and Gen 4, we now have to factor crosstalk, which we didn't have to do
Yes,
prior.
yes, there's a big piece of it for PAM4.
Yeah, and we are including package and PCB when we talk.
Yes.
Just wanted to clarify that.
Yeah, and we will try very hard. This is actually the proposal for small form factor, but we also will try very hard to make large form factor the same. Maybe we need to spend some money in the large form factor to make more exotic material, because our proposal later on you will see it makes sense why the small factor and the dual wide small factor will need to have the same kind of insertion loss, because to the PCB designer is on the baseboard side it's the same thing.
Right.
Great.
All right.
So as part of the NIC spec, we also made updates to several of the benchmarks and test integration and test fixtures. I'll talk more in depth on the thermal test fixture in my next presentation. That's right after this. But we had to upgrade the thermal test fixture to support PCIe Gen5. We also introduced the tall height version of the small form factor. This is allowed cards like the 400 gig and 800 gig to have more airflow for that particular form factor. The signal integrity test fixtures were updated to Gen 5. I got a slide on that next. And then we're still working on a management sideband test fixture. We've had this for a little while, but just due to priorities, it tends to be more the data lanes always gets more of a higher priority. The thermal comes the next priority. But as
Management is always the afterthought.
you know, system management is always the afterthought. I know we've had some presentations. The one prior, I like the fact that there's automated testing for management. I hope we eventually kind of work that way for the NICs as well. And then I know too, there was a question in one of the presentations about 4 or 5 presentations ago about fault management. You know, that's another area that we might be able to create some injection points in a fixture like this. Because ironically, I don't know about you, Damien or Hemal, but you know, when you're focused on the PCIe data lanes and things like thermal and then the front end, there's a lot of care that goes into that, and there's a lot of internal areas within the ASICs that allow you to have some test capability. But a lot of these sideband signals, I find is sometimes the most challenging. It's actually the slower speed single-ended I2Cs.
I 100% agree with you.
Yeah, those are, I find like we always run into a lot of challenges during development.
Yeah, I agree with you. Like initially we look at it like thermal test fixture, yeah, makes sense. SI test fixture makes a lot of sense. Most of high-speed signals actually have those. But what inspired you to do a management sideband test fixture? That is really uncommon.
Usually the case is when we're going through development, we're actually maybe building a new server with the latest Intel NIC or AMD CPU, along with the latest in NICs from guys like Broadcom, Intel, and a few others. And having to do that sort of debug in development, trying to find, is it us? Is it y'all? You know, is it, who's going to be the problem? Having these sort of test fixtures allows us to decouple that system integration point to figure out and pinpoint, is it really the NIC? Is it really the server? It gives us that kind of capability, just have another aspect to look at it.
Yeah, and I think a good example of this is NCSI hardware arbitration.
Yeah.
That is, we know from platform standpoint, like baseboard, NICs, everything need to work. If you have this kind of fixture, that'll really help with that.
Yeah, absolutely.
Cool.
So let's talk about the signal integrity test fixtures. I'll have Hemal hold up a few of these. So this is, that he's holding up the green one, is the compliance baseboard. This is used to measure PCIe data signals with NIC cards. So you have to break out, there's 16 data lanes, transmit and receive, plus and minus. I believe besides those numbers, there's also calibration. There's over 100 of these connectors on this particular board. The fact that it's PCIe Gen5, we have to use ultra low loss material. This is Megtron 6 that we've had to specify for this particular board to lower the amount of loss on this fixture. And then we also, the fact that Gen 5 is 32 gigahertz, we had to actually up to a different style connector. Ironically, or not ironically, but we wanted to leverage the fact that PCI SIG already has a prescribed test parameters, and a lot of test and measurement companies already have software that technicians can leverage to do automation. These boards, with the help of PCI SIG, are developed in a way where we can leverage what the SIG provides in terms of their test methodology, so that you can basically use the same cables, you can use the same software for these particular fixtures. The other board that
that's very smart.
Yeah.
Yeah. No reinventing the wheels.
Yeah. The other board that we didn't show here too is the CLB, the compliance load board. You load these into servers. So the fact that there's 16 data lanes on these boards, that's quite a number of connectors per SFF card. So we basically had to break out where 8 data lanes is on one of these particular cards, and then the other 8 data lanes is on the other card. So it allows now also motherboards to also be tested. We've already contributed prior, the Gen 3 and the Gen 4. This data package is already available today on our wiki. There's actually a company, UNH-IOL, the University of New Hampshire Interoperability Lab. They actually make these for sale. The Gen 5, as Damien just mentioned earlier, we just contributed that earlier this month. We're just kind of waiting for a few more steering committee votes to eventually get that fully released. But we've already enabled the IOL to basically put this up for sale too. But if you don't want to buy it and you want to build your own, you can pull down the files yourself and leverage what is already built or modify them for what your particular needs are.
One quick comment.
Yeah.
This kind of fixture, when we did like pre 1.0, if you guys remember working with Dell and Meta and like when we had our first NIC,
Yeah.
it really helped out to really make sure that we are going to be compliant and then do all initial testing before we had like 1.0 spec really finalized. So really, this is great.
Yeah, and the great thing is the fact that we built a board that is open and available for everyone. Everyone is, in essence, testing the exact same way, which gives us a common benchmark. Just quickly mention, and I'll talk a little bit more about it in the next presentation, but we also wanted to make sure that the thermal test fixture, which we had released during the Gen 3, Gen 4 days, also was able to run at Gen 5. And it is, the current version is able to do that with a couple of caveats, which I'll mention in the next presentation.
Cool. And here comes the new form factor that we're going to talk about just now. So the idea came from, like, we do have a large form factor that is good, but in all honesty, the adoption is kind of poor. We have NIC card vendors that kind of build it, but they couldn't really sell.
You can all fit in small form factor.
And yeah, mainly from the smart NIC use cases like 800G, well, future maybe 1.6T. So we kind of need a form factor that's bigger than this. And NVIDIA and HPE came to us and say, hey, what about creating a form factor that allow to have two small form factor fit in the same motherboard or a single double width form factor? So that came to be, that is a good idea. Why don't we do it?
Yeah.
And the discussion started weekly. We do have weekly call downs on this particular work stream that initially we do have disagreement between companies. Like we have two options how to work on this particular one, but we finally aligned that this is a form factor we're going to go with, like 6.188 inches. That's basically compatible with FLW, and you can see in the area that we have like QCT, we have Winstron, we have Jabil, that all of them have the two side-by-side NIC that compatible with FLW. The new NIC form factor we develop here would be able to plug in to those motherboard, mainly because we have aligned with FLW on the same pitch.
Yeah, and it gives us 32 lanes. So in the case of, instead of having to wait for Gen 6 and needing basically 16 lanes of Gen 6, we can actually use 32 lanes of Gen 5 to enable 800 gig. And a lot of other applications.
Yeah,
too.
and also like maybe a smart NIC, you need more space to put some DRAM and things like that. This is something capable.
This is enable new use cases for sure.
Yeah, those use cases that OCP NIC don't have a good solution for, which is currently on either PCIe Gen6 or some other proprietary form factors.
Well, we're just getting started with it too. We're actually now starting to develop the work streams. So if it's something of interest of your company that wants to get involved in the NIC, this is a perfect time to do it because we're just really in the fleshing out the ideas of what we want to do with a form factor like this.
Yep. So let's move on. This is our wiki. Didn't really change. The only thing was changed is our URL. Now it's server/NIC. In case you have saved the old one, server/mesh, it will actually direct you to this. And if you have anything, you can send us email or provide feedback through the feedback form here in this link. And the call to action is, join us in our monthly call.
Oh, absolutely.
Give us feedback, join us.
Yep, first week, Wednesday of the month. And just Hemal had mentioned, Spec 1.3 is actually in draft and it's currently in public review for the next 1-2 weeks. And we are developing the double width small factor. We want your feedback. Yeah, still things are not done. How to configure the NIC and the rules and things. We have just discussed it with Intel and the team just 2 days ago in a face-to-face.
Even the name, we're still trying to decide.
Yeah, even the name. Yeah, right. We are just changed
DW,
very
we're
recently.
still working on that. Thank you.
Yep. And yeah, thank you. I think our time is up.
Thanks.
Thanks, John.